Imagine you need to implement a floating block on your page. The block appears when the user scrolls the content area and moves slowly down when the user continues to scroll. Which experience you would want to show to the people? This one or this? Probably the second one, right? The first one is clearly not feeling well. Fortunately, the second way is very easy to implement. Just need to know a few composition techniques. Welcome to the Advanced React course, episode 2. This time we are going to solve the problem of lagging scroll experience and learn in the process a few composition tricks that can help with problems like that, understand what the element in React is and why we should even care about it, look into the basics of React reconciliation and diffing and understand how React really triggers re-renders, and finally learn about children in React. Okay, let's look at the problem. We have a scrolling experience on the left that we want to turn into the scrolling experience on the right. Code for the left experience looks like this. An app with a scrollable div. Inside this div, we have a bunch of heavy components. And while implementing that flying block, we introduced some state that holds the current scrolling position, attach the onScroll handler to the div and set our state there, and added the floating block that will change its position based on the state value. From the first episode that covers how React re-renders nested components, we can already tell why this block behaves so badly. On every scroll, we are changing the state. Every state change causes a re-render of the app component, and that causes all the components rendered inside it to re-render themselves. As always, every component down the render tree from the component with the state will re-render. And again, from the first episode, we know that we can improve this situation by moving the state into a smaller component down the render tree. In this case, it's not that easy though. Our setState function is attached to the div that is wrapping all those heavy components. So we can't just move them. That will achieve nothing. There is a cool trick here, however. We can move the div itself with the state attached to it, then create a content prop on that smaller component, pass all those heavy components through that prop, and render them where they are supposed to be. This works wonderfully. Scrolling is blazing fast now. And it doesn't make sense. Didn't I just say that React always re-renders all components down the render tree? Technically, those heavy components are still rendered inside that tree. How come they are not re-rendered when the state changes? To make sense of all of this, we need to understand a few new things. Let's start with the elements, or actually components. What is a component? Here's the simplest one. It's just a function, actually. If a component has props, those are just the function's first argument, nothing more. What makes a simple function a component is its return. A component is a function that returns an element. That thing, the nice HTML-like syntax that we use daily. When React renders a component, it takes the elements it returns and converts them to what they should represent on the screen. This is an element of a child component. The element of the parent component would be this. Element is just an object that describes a component. In fact, the nice HTML-like syntax is nothing more than syntax sugar for React create element function. We can even replace that element with this, and everything will work as expected. If we console log our element, we will see an object that has a type property. Type tells React what should be rendered from this element. If the type is a function, then React will assume that this is a component and will trigger rendering of that component. If the type is a string, React will convert it into a DOM element right away. Now to rendering. What we know as rendering is React taking the root component, calling its function, taking elements that are returned from this function, and converting them into DOM elements. If some of those elements have a component as a type, React calls this function as well and iterates over its return. And so on until there are no more functions and the entire tree of DOM elements is built. After that, React sends that entire tree to the browser and we see our beautiful interactive interface. At some point, a user interacts with it and it's time to trigger a re-render and update the interface. This is where the diffing and reconciliation algorithm kicks in. Starting from the component that triggered state update, React starts building another tree of objects using the new state value, comparing those elements in the process. It uses shallow comparison for that, which for objects means it compares them by reference, not by value. If the comparison returns true, React will think that this element hasn't changed and will skip its re-render and as a result re-render of everything inside. If the comparison returns false, React will proceed further and compare the type value of that object. If the value is exactly the same, React will trigger a re-render of the component that is represented by this element. Let's look at our parent component. The return value of it is an object that was created inside the parent function. So even if it looks the same, the shallow comparison of the object before and after will return false. Next step, compare type values. Those will be a reference to the exactly the same child function. So this comparison will return true and React will re-render child component, which we already know as a standard React behavior, but it's nice to have proof of it, isn't it? Now imagine I pass that child as a prop. What will happen in this scenario? State update in parent is triggered, React extracts its return object and compares it with the previous one. And in this case, the shallow comparison of those objects will return true. The child element is passed as an argument to the parent component. It's created outside of the parent function and is never recreated when the function is called. As a result, React will skip re-render of the child and everything inside. Going back to our problem from the beginning, this is exactly what we did for our scrolling component. When setPositionState update is triggered, React will compare content object before and after. The comparison will return true, and all our heavy components that are hidden inside won't re-render. By the way, props are also part of the element object. If we console log it, we will find them right there, near the tab. And one last thing. What will happen if I rename the content prop into children? The answer is nothing. Props are just an object that we pass as the first argument to our component function. Everything that we extract from it is a prop. Renaming content to children will change absolutely nothing. They will still be part of the props. The code will behave exactly the same way. But the cool thing about children prop is that we have a special syntax for it in JSX. That nice nesting that we use all the time with HTML tags and never pay much attention to it. Actually exactly the same, including the element object. And here's your performance crawling experience implemented with the cool composition technique. Passing elements as props is useful not only when we're trying to solve performance problems, by the way. We'll take a look at more use cases in the next video.